Hello, guys. My name is Desmond, and I welcome you to my YouTube channel. Ladies and gentlemen, please do allow me to say it's very much important that I say it's very, very much important because, good people, what I'm about to say is very, 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 very much important. Okay, guys, a day without learning something new, it's a day wasted. Okay, so please do make sure that by the end of this lesson or by the end of each and every question, you learn something new. Okay, so guys, as you can see, for today's lesson we'll be looking at electric circuits. Okay, so this lesson is actually suitable for learners in grade 10, 11 and 12. And again, if you're upgrading this subject, physical sciences, this lesson is also suitable for you. Okay, ladies and gentlemen, you just need something to write and again a glass of water, nothing much. But I would advise you to spend much of your time listening to the tips that I'll be giving you, trying to understand the tricks that I'll be giving you, and most importantly, ladies and gentlemen, as soon as I'm done with this lesson, I'm just going to make it available on our YouTube channel. So in case if you're watching this lesson from one of my platforms, it could be Facebook, Instagram or TikTok, just know that we have done a full lesson on our YouTube channel. So in case if you want to watch the whole lesson, please do visit my YouTube channel. Make sure to subscribe and go under the playlist. I think it's free live online lessons. You can just click there and you'll be able to find this lesson together with a lot of informative lessons that we have done. Okay, so this is just in preparation for your exams. So ladies and gentlemen, as you can see, we've got a diagram below. This is question 12, and most importantly, you are advised to start each question on a new page. Very, very much important, ladies and gentlemen. I've indicated exactly why it's important for you to start on a new page. Okay, so guys, you can see I've tried to draw this diagram by hand there. So I think, as I always do, it's actually good that we first try to analyze that circuit before we even start with the questions. Okay, so ladies and gentlemen, I'll just quickly read through the statement, and then from there we'll try to analyze that equation, that diagram. Okay, so consider the circuit below. Okay, consider the circuit diagram below. The internal resistance of the battery and resistance in the wires can be ignored. Ladies and gentlemen, this is all the statement that we're given. Most of the information is there on the diagram given. Okay, so guys, I'm just going to take away my screen. Remember, ladies and gentlemen, that diagram, not necessarily the diagram, but the question paper, it's there on my Telegram channel. If you've got a Telegram account, you can just search for solving exam papers. You'll be able to access this question paper. Okay, so this question paper is actually for a November exam paper of 2018. Ladies and gentlemen, as you can see, can I please just quickly try to redraw that circuit diagram in parts and explain exactly what's going on. I hope you'd be very much happy to see what I'm about to draw here, ladies and gentlemen, and most importantly, explain. Okay, remember guys, the whole of this thing, okay, the whole of this thing, it's called a battery. Okay, I hope you remember from the statement they said the internal resistance of the battery and resistance in the wires can be ignored, but I just wanted that part where they say the internal resistance of the battery. Okay, so ladies and gentlemen, what is a battery? Okay, very, very much important, ladies and gentlemen. So a battery is made of two or more cells. Okay, so as a small line and a long line, it's one cell. Okay, a small line and a long line, it's a cell. Okay, so that means we've got two cells. Okay, so anything greater than two cells, it's a battery. Very, very much important, ladies and gentlemen. I hope you fully understand. Okay, so why do we have to have this long and a short line? Okay, guys, very, very much important. You know, when you've got a cell which is something which looks like that, okay, we know very well that we've got a positive and a negative. Okay, so each and every cell has got a positive and a negative, which is the reason why we've got a long and a short line. Okay, good people, you must ask this kind of questions to your teacher, your mentor, or whoever who's teaching you physical sciences. You must ask them, how do I see the positive side of that cell or the positive side of that battery, and how do I see the negative side of that battery? Very, very much important, guys. So remember, this information that I'm providing to you now with regards to the cells and the positive and the negative, it's not for the purpose of you being able to answer the question. It's just for your general knowledge, okay, so that you fully understand what's happening as far as a battery is concerned. Okay, very, very much important, ladies and gentlemen. So now a long line represents the positive side of the battery. Okay, very, very much important, ladies and gentlemen. The negative side of the battery is represented by a short line. Okay, so that means you've got two cells. Okay, positive, negative, positive, negative. Okay, ladies and gentlemen, it was very, very much important for me to understand the positive and the negative side of the battery. Okay, why? Because by knowing which side of the battery is positive and which side of the battery is negative, I then understood that the electrons move from positive side of the battery all the way up to the negative side of the battery. Okay, very, very much important, ladies and gentlemen. So that means the current flows from the positive, then flows through the circuit if it's series, and in that series, if you've got a parallel, then when it gets to the parallel branch, it splits and then it joins, then it connects to the other side of the battery, which is on the negative side of the battery. Guys, very, very much important that you understand this part. Okay, so for now we'll just leave it at this stage. I hope you fully understood. The whole of this is referred to as a battery. Guys, before I forget, there's something which is known as R. Okay, ladies and gentlemen, very, very much important. What is this R? Guys, this small letter R in most cases is referred to as an internal resistance of the battery. Okay, listen to what I'm saying, guys. Internal resistance of the battery. Okay, guys, if we've got something called the internal resistance of the battery, that means there's something called EMF. Okay, ladies and gentlemen, very, very much important. Let's say, for example, as an example, the EMF of this battery is 10 volts. Okay, so because of the internal resistance of the battery, not all the devices or the electrical appliances will use the whole of that 10 volts. Why? Because there's an internal resistance which resists the whole of that 10 volts to be used. Okay, just a practical example, ladies and gentlemen. let's say, I think, let me just quickly wipe all of this and give you something that made sense to me at the time when I was studying this chapter of electric circuits. So, ladies and gentlemen, it doesn't necessarily mean that what I'm about to explain to you is what the teacher should teach you. And again, don't expect anyone to teach you this information. It's actually the information that I discovered by myself, and I sticked to that information, and it only made sense to me. Okay, so guys, let's say this is that box. This is that box where you punch in all of that information to insert to recharge electricity, if I may say it that way. Okay, so let's say, remember, this is a box in your house, right? So you've got let's say you've got light bulbs, you've got what else, microwave, let me just say microwave, and again you've got let's say a kettle there, and again let's say you've got a stove. It doesn't necessarily need to look like a stove. Okay, ladies and gentlemen, very, very much important. Please just ignore the background noise. I assume you fully understand and hear exactly what I'm saying. Okay, so let's just focus on that for now. So, ladies and gentlemen, they sent you to go and buy electricity of let's say 100 rand. Okay, and let's not use the unit as rand, but instead volts. Okay, so guys, what actually happens here is that because within this box, okay, this is just as an example, because within this box there's an internal resistance. Okay, that means maybe 20 volts will be used by that bulb light, the bulb, and then 20 volts will be used by that microwave, then 20 volts will be used by that kettle. So another 20 volts will be used by the stove. Okay, so let's see, it's 20, 40, 60, 80. Okay, so that means only 80 volts was used by the electrical appliances. Okay, ladies and gentlemen, what happened to that 20 volts? Because you went to buy 100 rand worth of electricity. Okay, so that 20 volts, ladies and gentlemen, it's lost within that box. Okay, because as you punch there, it also needs a portion of electricity so that it shows on the screen, and again it loads your electricity. Okay, so that means for the whole of that it used 20 volts. Okay, so ladies and gentlemen, in short, when you've got 10 volts as EMF, okay, so that means not all of the 10 volts will be used by the resistors. Okay, so you might find that maybe a 9.5 volts will be used by the external devices connected on the external side of the circuit. Okay, so what happened to the 0.5 volts, ladies and gentlemen? So this is what showed that 0.5 volts. Remember, ladies and gentlemen, V, it's equals to I. In this case, it will be small letter r. Okay, very, very much important, ladies and gentlemen. This is the formula for that V as a result of the internal resistance. Okay, so guys, we also have V, which is equals to I. Notice the difference, capital letter R. Okay, very, very much important, ladies and gentlemen. What is the difference between that small letter r and that capital letter R? Good people, remember, an R is that small r over there, okay, which refers to that R of the internal resistance of the circuit. Okay, very, very much important, ladies and gentlemen. Capital letter R refers to the resistance or the resistors connected on the external part of the circuit. Okay, very, very much important, ladies and gentlemen, that you understand that everything that I'm saying now, it's not what you should expect your mentor, your teacher, educator, whoever, to teach you this kind of information. It doesn't necessarily mean that it's 100% related to this chapter of electric circuits. It only made sense to me when I was studying this chapter, because I had to somehow come up with a relevant story so that I don't easily forget that we've got something called EMF, and again what EMF does to the circuit. Okay, so this is the only information that made sense to me at the time when I was studying this chapter. Guys, I want you to notice something. I'll just remove all of this information. I hope you fully understood. So ladies and gentlemen, we've got a formula which says EMF is equals to, I'm not sure if you remember, guys, but it's I into capital letter R plus small letter r. Okay, so ladies and gentlemen, we can further simplify or work out this formula. You can just multiply by I, multiply by I. Okay, so you've got I capital letter R plus I small letter r. Okay, ladies and gentlemen, very, very much important that you notice the difference. The I is the same. That's why it was I for both of these. Okay, guys, very, very much important. What is the difference now? The difference is R, which is capital letter R and small letter r. Okay, what is this capital letter R, ladies and gentlemen? This is for the external resistance. Okay, external resistance. Ladies and gentlemen, very, very much important. So the external resistance refers to these resistors connected either in series or in parallel. Okay, guys, we've got small letter r. What is this small letter r? Is the internal resistance. Okay, is the internal resistance. What internal? Ladies and gentlemen, the internal resistance of the battery. Okay, very, very much important that you understand the difference between the two. Okay, so guys, if we've got the internal resistance of the battery given as a certain amount, which could be 0.1, 0.5, 0.9, whatever internal resistance it is, that means not all of the EMF will be used. Okay, very, very much important, ladies and gentlemen. But if the internal resistance of the circuit is 0 ohms, okay, or it can be ignored, ladies and gentlemen, it means this part of the formula falls away. So that means you have IR. Okay, so that means that 100 rand worth of electricity will be used. So each of those electrical appliances were going to share 25 volts. Okay, why 25 volts? Because that box, it didn't need some electricity to enable you to load the 100 rand worth of electricity. Okay, guys, very, very much important. It doesn't end here. Okay, I can just go on with this formula to say, remember, this is V. Okay, you remember the formula of V is equals to IR. Okay, so that's why they say this is V external. I'm not sure if you understand, guys. What makes it V external is because of that capital letter R. Okay, guys, this is added to, this is that addition sign. Okay, this is added to V internal. Ladies and gentlemen, that's why we've got V external and V internal. Guys, what makes it V internal? Ladies and gentlemen, that small letter R makes it V internal. Okay, so what does it really mean for us to have a V external and V internal? Guys, very, very much important. It's very, very much important that you listen very carefully, and again you understand what I'm explaining to you guys. It means the EMF or the electricity that you went to buy, okay, the total electricity that you went to buy, which was 100 volts in that example, it's equals to electricity of the external electrical appliances plus the electricity of the inside of the box, okay, or the electricity used by the box when you were loading that electricity. Okay, so now you can play around this formula, ladies and gentlemen. Sometimes, depending on what the question wants, they might give you information for the external and give you the information for the internal, which is normally R, and then from there they say what is the EMF. Okay, guys, I've done a question where we were dealing with EMF. I would advise you to check out that live lesson. So for today's lesson, we are dealing with the circuits without the internal resistance of the battery. Okay, ladies and gentlemen, very, very much important. Thanks to there's one of my learners who actually requested that I go deep and explain in details, because she enjoyed that lesson, and I assume she was able to see that I can actually provide some valuable information with regards to this chapter. So she actually requested that I just do a lesson. Okay, but because it's already late and very soon you'll be starting with your exams, I think it's better if we do it this way, where I just treat a different question without internal resistance. Okay, very, very much important, ladies and gentlemen. Remember what I wrote there in red, it shouldn't be there. Okay, it's not part of what we are given in the question paper. Okay, so guys, let me now continue with the external part of the circuit. Okay, so that you fully understand what's going on there. Okay, ladies and gentlemen, we've got a resistor there. It doesn't really matter if it's 4R, but for the purpose of me explaining what I want to say, let me just do these and not write those values there. Okay, remember, ladies and gentlemen, you've got current flowing from the positive to the negative. Okay, let me just do this, ladies and gentlemen, which is something that made sense to me at the time when I was studying this chapter. So, ladies and gentlemen, what I'm about to do, remember, do not expect your teacher or whoever to teach you this information. It was just for me to understand this chapter. Okay, remember, we said current flows from a positive to negative side of the battery. Okay, so let's assume this is the current. Okay, so these two lines represents the current. Okay, someone may just think of it as water. Okay, so remember, guys, this is the wire, so this will be the current flowing through the wire. Okay, if you assume it to be water, then it means it will be water flowing within a pipe. Okay, so guys, this is how the current flows. Very, very much important, ladies and gentlemen, that you understand what I'm doing here. Okay, so this is how the current flows there. Guys, when this current gets to that point where you have a split of lines, okay, very, very much important, guys, that you understand exactly what's happening when the current gets to that point. Guys, it splits. Very, very much important. It splits. Part of the current will flow on this side, and part of the current will flow this side. Okay, and when it gets to that point there, okay, can you see those wires? Those wires which splits, they now join. So this is the wire, this is the wire, and then they join there. As soon as they join, now it's just one wire. Okay, I'll shortly explain in terms of the pipe. Okay, so now it goes to the negative side of the battery. Okay, and it doesn't end there, but remember, it just continues, and the circle continues until your electricity is finished. Okay, so ladies and gentlemen, that's why we've got something called a switch. Okay, so if the switch is open, okay, if the switch is open, can you see no current is going to flow because there's a disconnection. Okay, so these wires must, when you actually turn on the switch, you are actually connecting these wires. When you turn it off, you're disconnecting. That's why when you disconnect, there's no current flowing, then it means the light won't glow. Okay, so in this case, it means now the switch is closed. Okay, so we have a switch being either closed or opened. Okay, ladies and gentlemen, very, very much important that you also understand that we've got something called a switch. Okay, guys, from normally from the positive side of the cell or the battery, that's where you have a series connection. Can you see it's just one wire or just one pipe? As soon as it gets there, it splits. So that means we now talk about a parallel connection. Okay, so that means this would be considered as series connection. So anything connected between that line from there all the way up to there would be connected in series. Okay, so now because it splits at that point, then we have a parallel connection and we also have a parallel connection. Okay, so you can see on this line we just have one connection. Okay, but along this side of the parallel connection we've got 3 resistors connected there. Okay, but most importantly, ladies and gentlemen, you should notice that these are connected in series. Okay, so it's more like you've got parallel within parallel, you still have series. Okay, so that means if you add all of these resistors, okay, so you add all of them, after adding all of them, then that means you'll only have one resistor connected in parallel to that one. Okay, ladies and gentlemen, very, very much important that you understand what I'm explaining to you guys. So guys, think of this as water. Okay, so you've got water flowing from that point, then it flows, it flows, it flows. Then guys, obviously, let's say this is the pipe. Okay, obviously guys, you've got some water coming from this direction. Remember, this is that point, and there is that point there. So guys, obviously, water is going to pass through. Okay, and then part of the water will go in that direction. Okay, so what happens is, if you've got more resistance on this side, so that means more water will flow that side. Okay, so that means if you've got more resistance on this side of the circuit, then less current will flow there and more current will flow that side. Okay, because obviously on this side it's being resisted from flowing. Only little of the current will pass through, but most of it will pass through that side. Same as water, guys. If there's a bigger opening that side, more water will flow through that side. Okay, if there's more resistance, when it resists, it means you're trying to actually close you're trying to close that pipe. Okay, so that's why we say there's more resistance. Okay, you're resisting more water to flow through that side. Okay, guys, I'm not sure if I've explained it in detail. Remember, this is actually that pipe, that pipe there, then it goes like that and then it joins. Okay, guys, very, very much important that you understand what I've just explained. In case if you feel like I've missed something or you want me to go deeper, guys, please do comment, just like that lady who did. It's unfortunate I forgot her name, but a big thanks to her. She actually commented on that lesson of the first lesson that I did for electric circuits. So if you're still watching this lesson, the lady who commented on the first lesson, please just do indicate that it's you, because your suggestion is actually going to benefit a lot of my students. Guys, let's now move on to the questions. Okay, guys, we are now about to start with the main business of the day. I've just read that statement there. I'm not sure, guys. I think I've also covered that part. Remember, this is a connected in series within a parallel connection. Okay, very, very much important. So that means if you just want to combine all of these resistors connected in series, you just this 3R, 2R, 1R, it's 6R, then you have 4R and 6R connected in parallel. But be careful, guys. You've got a V which is connected on 2R. Okay, in case if they ask you a question related to that specific 2R, okay, remember to forget about the combination which is 6R. Okay, guys, I think you'll learn some more as I continue answering the questions. Okay, so let's check. Our very first question says calculate the value of resistor R if the total resistance of the circuit is 4.8 ohms, and this question is allocated 3 marks. Okay, ladies and gentlemen, very, very much important. Please do make sure to like this video if you feel like the information that I'm giving to you, it's either relevant or important, or if it has opened your eyes in relation to this chapter. Guys, just give it a like. Okay, so I hope you've understood the question. They say calculate the value of the resistor R if the total resistance of the circuit is 4.8 ohms, and the question is allocated 3 marks. Okay, so ladies and gentlemen, what they want you to calculate is that R. Okay, so I hope you realize that if you can be able to know the value of that R, for you to know the exact resistance of that resistor, you just multiply by R. Okay, you just multiply 4 by R, you know the exact resistance of that resistor. You just multiply by 2, you know the resistance of that resistor, and that resistor you just multiplied by 1, then you know the resistance of that resistor. Okay, ladies and gentlemen, very, very much important, your first step. Okay, this is why I'm going to take this first step. They said calculate the resistor, the value of resistor R if the total resistance of the circuit is that. Okay, now I know very well that I've got a parallel connection, and within the parallel connection I've got a series connection. Okay, ladies and gentlemen, very, very much important that you understand that part. Okay, so now this is 12.1. remember, guys, you've got 2 types in which you can calculate the resistance of a parallel connection. Okay, so this is the first way in which you can calculate the resistance of let's say R1 1 over R2. Let me just use small letter R's. Okay, but remember, do not confuse this with the internal resistance. Internal resistance would be small letter Ri. Okay, so guys, we can now substitute. Why did I use this formula, ladies and gentlemen? It's because they said R total, okay, it's equals to, what was it? It's 4.8 ohms. Okay, so they didn't want to say the total resistance of the parallel connection is 4.8 ohms. Why? Because they didn't want to they didn't want to make it obvious to you that you should use this formula. Okay, so they are trying to test if you are able to see and notice a parallel connection. Okay, it's very, very much important, ladies and gentlemen, that you are able to see a series connection and a parallel connection. Okay, guys, please do ignore the external noise that you hear from the kids playing outside. Okay, I hope you're able to clearly hear what I'm saying, and again, you fully understand. Okay, I apologize if it makes this lesson not clear, but I assume you're able to hear exactly what I'm saying. So guys, let's now continue with the substitution. Okay, so ladies and gentlemen, we've got 1. This is 1 over, what is R parallel? R parallel is 4.8 ohms. Okay, and then this is 1 over R1. Very, very much important, guys. R1 in this case will be that 4R. Okay, it will be that 4R. Okay, R2 in this case, it's going to be all of this. Why all of this, ladies and gentlemen? It's because you are using a formula for calculating the parallel, the resistance of the parallel connection. And you know, when you use that formula, it means you have this type of connection. Okay, but there you haven't got this type of connection, then you must make it to look like this type of connection. Okay, where you don't have any other series connection within the parallel. Okay, so guys, this is that 4R, right? Then you add all of these which are connected in series to make it just one resistor. Okay, obviously it's 6R. It's 3 plus 2 is 5 plus 1, it's 6R. Okay, so now that means R2 it's going to be 6R. Okay, guys, very, very much important that you understand this part. Otherwise, you won't understand as I continue. Okay, so that means our R1 is 4R. Okay, plus what is our R2? I've just explained is a 6R. Okay, guys, to easily solve this type of questions, ladies and gentlemen, let's just multiply each and every term by R. Okay, why do we multiply it by R? Is because we just want to remove that R at the bottom. Okay, you know what you do on the right, you do on the left. Sorry, very, very much important, ladies and gentlemen. So that means we multiply by R, we also multiply this by R, we also multiply that by R. Okay, so that means you've got R over 4.8 on this side, so that R is going to cancel, that R is going to cancel. You've got 1 over 4 plus 1 over 6. Okay, now you can add these two on a calculator. I'm not sure if I've got my calculator next to me. Oh, there. I just got my calculator, but I'm sure you're done with the calculation. So you just punch 1 over 4 plus 1 over 6. Then it's 5 over 12. So you just have 5 over 12 there. So that means you've got R over 4.8, which is equals to 5 over 12. Okay, so for you to be able to just remain with R on the left side, that means you've got R, which is equals to 4.8 into 5 over 12. Remember, you just cross multiply. Okay, you cross multiply, then you divide by 12. This is that 12 as denominator there. But otherwise, because you don't need to cross multiply, you can just multiply by that, so that you remain with R, and you punch all of this on a calculator. So I've got that already. Then I can just multiply by 4.8. I just multiply by 4.8, then I get 2. So that means this is 2 ohms. Okay, ladies and gentlemen, very, very much important that you know how to calculate the total resistance of a parallel connection. So can we just say R is equals to 2 ohms, so that when we continue with our calculations, I think from time to time we might need to refer to that. Okay, so guys, before I forget, something very, very much important, ladies and gentlemen, this is not the only way in which you can calculate the R parallel. Okay, there's this formula, guys. I'm sure you know this formula, and you like using it a lot. Okay, so let's just say R1 times R2 over R1 plus R2. Okay, ladies and gentlemen, very, very much important. Remember, we've got our R1 as 4R, okay, and we've got our R2 as 6R. Okay, so this is the second option that you can apply. Okay, and remember guys, this question, it was allocated only 3 marks. So for you to be able to get to that final answer of 2 ohms, I can guarantee that you will get all the marks. Okay, so now what is our R1? Our R1 is 4R, okay, multiplied by 6R. Okay, so our R1 is still 4R. The difference is at the bottom we've got a positive sign, then our R2 is 6R. Okay, guys, it's just a matter of you substituting into that formula, and then from there you solve everything. Okay, so 4 times 6, how much is it? Let's see. 4 times 6, it's equals to 24. Okay, it's equals to 24. Obviously R times R, it gives us R times R. Okay, if you like, you can write R squared, it doesn't really matter. Okay, then this is divided by, obviously 4R plus 6R is 10R. Okay guys, very, very much important. Remember, they've just told us that the R parallel is 4.8 ohms. Okay, so that means this is 4.8 ohms. Very, very much important, ladies and gentlemen. So now this R cancels with that R. Okay, so that means you've got 4.8, which is equals to, what is 24 divided by 10? You might find that maybe it's 2.4. Let's see. Yes, it's 2.4. So that means you've got 2.4 R. Okay, remember, this is that R. Okay, very, very much important, ladies and gentlemen. So now that R is equals to, you obviously divide by 2.4 on both sides so that it cancels and you remain with that R. Okay, so 4.8 divided by 2.4, let's see how much you get. 4.8 divided by 2.4, it's equals to 2. Can you see, guys? And that means this is 2 ohms. Okay, so guys, very, very much important that you fully understand what's going on there. So remember, this question is allocated 3 marks. Okay, so guys, let me quickly show you how you score some marks. Okay, so obviously guys, that's why I like physics. They give you a mark just for writing the correct formula. Okay, from there they give you a mark for correct substitution. Okay, very, very much important, ladies and gentlemen. Then they give you a mark for the final answer. Okay, so this is how you score your 3 marks for the first question. I hope you're ready to move to the next question. So guys, remember, for this question we know R is 2 ohms. So let's just at all times remember that R is 2 ohms. Okay, so now let's move to the next question, which is 2.2. I think it should be 2.2. Let me quickly check. No, 12. Sorry guys, it's 12. I just know it's 0.2, so should have noticed it's 12.2. So ladies and gentlemen, let's read the question for 4.2. Okay, so the question for 4.2, they say calculate the reading on the voltmeter if the current through the 4R resistor is 1.8 amperes. And this question is allocated 5 marks. Guys, this involves a lot of thinking, okay? And most importantly, you should be confident with what you'll be doing. Okay, very, very much important, ladies and gentlemen. They say calculate the reading on the voltmeter if the current through the 4R resistor is 1.8 amperes. Okay, so guys, what they are saying is the current flowing there is 1.8 amperes. Very, very much important, ladies and gentlemen. Okay, so remember, R is equals to 2 ohms. Okay, so that means the resistance there, can we just quickly do it, guys? The resistance there, it's actually 4 times 2. Do you agree? Do you agree with me that it's 8 ohms there? Do you agree with me that it's 2 ohms there? Ladies and gentlemen, do you agree with me that it's 4 ohms there? Good people, do you agree with me that it's 6 ohms there? Guys, I'm guided by the fact that I managed to calculate that my R is equals to 2. Okay, so now check how tricky is this question, guys. So this question says, calculate the reading on the voltmeter. Where is the voltmeter? There is the voltmeter. But look at what they do, guys. They're just giving you an information which is way far from that V. Okay, they say, what is it? If the current through the 4R resistor is 1.8 amperes. So they want that V, but they talk about the current which is flowing through that side, okay? Which means it remains your responsibility to know what is the current flowing through that side, okay? Very, very much important, ladies and gentlemen, that you understand how the circuits works, okay? So, guys, this is now our starting point, guys. So, you need to find the V of that side of the 4R resistor. Remember, V of the 4R, let me not say, okay, it's fine, let me say for the 4R, which is equals to IR, okay? For ease of reference, let's use that 4, which is equals to, what is the I flowing there? It's 1.8 amperes, okay? What is the R of that 4R? Obviously, we know it's 2. I mean, it's 4. How was it 4? It's 8. How was it 8? It's because it was 4 times 2, which is that 4, and that R, which is that 2. Guys, I hope you fully understand that part, okay? So it's 1.8 multiplied by 2 times 4, which is equals to 14.4, okay? Which is equals to 14.4 volts. So that means if we connect a V there, okay? If we connect a V there, it's going to read 14.4 volts. Ladies and gentlemen, very, very much important. If you remember from that previous lesson, guys, I've just indicated that the V calculated on this side, okay, it will be the same for V for this side, okay? But remember, most importantly, for V of this side, when you don't have any other connections in series, if you've got those connections in series, then you must add them all and find just one R. Then you know that V is equals to the V of all of those R's, okay? Very, very much important, ladies and gentlemen, that you understand this part. So why did we have to calculate the V of that 4R? Is because we know if we get that V, then we'll know the V of that total, okay? So obviously that means the V of the 6R, okay? V of 6R. Guys, if you forgot the 6R, if you started this lesson in the middle, please make sure at the end you start watching this lesson, because you'll understand what I mean by 6R. Is the combination of these R's so that we make it 1R, then we know that V is for 6R, okay? Very, very much important, ladies and gentlemen. Obviously, we know at all times V, regardless of whether it's V of 6R or V of whatever, we know V is IR, okay? So we just say V of 6R so that we don't forget that it's not a V for 2 ohms, okay? 2R, okay? Guys, what is now the current flowing through that side? Very, very much important, ladies and gentlemen. We don't even know, we don't even know the current flowing through that R. Okay, so that means we're actually trying to calculate the current flowing through that side, that 2R. Okay, so this is what we're looking for. The current flowing through the 6R. Okay, multiplied by what is that R? Obviously we know, guys, that R, we know that it's actually 6R multiplied by 2. Okay, do you agree, ladies and gentlemen? So that means it should be 6, 10, 12. So that's why 6 times 2 is equals to 12. Okay, 12 ohms. Okay, so guys, what is that V? Obviously the V of the 6R is 14.4, ladies and gentlemen. Why? Because I've just explained that the V that we calculated on this side, which was 14.4, it should be the V of this side. Okay, that's why we are saying the total of these resistors, which is 12 ohms, its V is the same as the V of that side. Okay, guys, if you don't understand, please just do comment so that I have an idea if I'm actually confusing you guys or I'm making this lesson easier to understand. Okay, so that means I of 6R is equals to 14.4 divided by 12. Okay, so you can just say 14.4 divided by 12, then you get 1.2. Very much important, ladies and gentlemen. So that means the current, okay, so that means the current flowing through that side of the parallel connection is actually equals to 1.2. Okay, so remember, guys, the current flowing through the 3R is still 1.2. Current flowing through the 2R is still 1.2. Current flowing through that R is still 1.2. Why? Because it's flowing through a series connection. Okay, so there's no split of water going through in two different ways. Okay, don't be confused by this. This is just a device that reads the potential difference across that 2R resistor. Okay, very, very much important, ladies and gentlemen. So that means now we can be able to calculate the V, which is that V of 2R, because it will be equals to IR. Okay, guys, what is the R flowing? The current flowing through the 2R. I've just explained it's 1.2. Okay, very, very much important, ladies and gentlemen. What is the R of that 2R? We know, guys, is 2 multiplied by 2, which is that 4. Okay, so now we have 1.2. We have 1.2 multiplied by 4, which is, guys, it's 4.8 volts. Okay, ladies and gentlemen, very, very much important. So that means the reading on that voltmeter will be 4.8 volts. Okay, so guys, that means if you were to calculate the reading on that V and again on that V and add all of those V's, okay, they must give you 14.4 volts. Okay, so I'm giving you a homework, guys. Calculate the V of that 3 there, calculate the V of that R there. When you're done, add them together and tell me how much you get. So I'm saying you must get 14.4. If you do it and you get 14.4, please do come back to this video and comment and say you've got it correctly, so that if you got it wrong, then I'll try to see how I can help you with that. Okay, so guys, before I forget, remember this question was allocated 5 marks. Okay, very, very much important, ladies and gentlemen. So this is how you score your marks. Okay, they normally give you a mark for choosing the right formula. Okay, they give you a mark for final answer. From there, for choosing the right formula, again they just give you a mark, and again, but I don't think they will give you a mark, ladies and gentlemen. I don't think so. They will just give you a mark for a, what is it, for that V. Okay, they will give you a mark for that, and again they will give you a mark for calculating that current flowing through that side, and again they will give you a mark for correct formula. So that means it's either they give you a mark here or there. So if they give you a mark there, they won't give you a mark again here. Okay, so it's just for you choosing the right formula. So they'll just give you a mark for correct substitution, and again a mark for your final answer, which is what they wanted you to calculate. So this is what they wanted you to calculate. Okay, so if you got it correctly but used a different method, it remains the responsibility of whoever marking your paper to find exactly where to give you all of those marks that you deserve. Okay, ladies and gentlemen, very, very much important that you understand this information that I'm giving you. Okay, this information is very, very much important, ladies and gentlemen. I went far with this information. Okay, it's not misleading at all. Do not expect it to come from your teacher, your mentor, whoever. This was just for my personal understanding. Okay, so guys, moving to 12.3, they say calculate the energy converted in resistor 4R in 2 minutes. This question is allocated 3 marks. They want the energy, guys. They want the energy. Okay, what is the unit for energy? We know it's joules. Okay, so ladies and gentlemen, you just go to your formula sheet. Let me just quickly check if you're given the formula sheet. Oh yes, of course you're given the formula sheet, guys, but because I know it by heart, you can just go to your formula sheet and check if you've got that formula. So you've got this formula, guys, which is W is work and energy are related, they are measured in joules. Okay, so guys, you've got a work which is equals to I squared R delta time. Remember, this is a delta, guys. So delta is a Greek word which means change. Okay, don't worry much about it. Just know you've got three variables or quantities, which is time, R, and I. Okay, ladies and gentlemen, this formula, remember, I squared is the same as I times I, isn't it? Multiplied by that R, multiplied by change in time. Very, very much important, ladies and gentlemen. So that means you remember IR. Okay, what is it? IR, this thing is the same as V. You know, we've been writing that formula to say V is equals to IR. Okay, so that means this is the same as V multiplied by I, which is that I multiplied by change in time. Okay, very, very much important, ladies and gentlemen. So what is the V of that 4R? Remember, guys, the question wants us to calculate the energy converted in resistor 4R in 2 minutes. Guys, very, very much important. What is the V of that 4R? We know the V is 14.4. What is the current flowing there? We just calculated it. It's 1.8 amperes there. Guys, very, 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 very much important that you understand that we measure time in seconds, especially with this chapter of physical sciences. Okay, so if you're given time in hours, convert it to seconds. If you're given time in minutes, convert it to seconds. Guys, if you're given time in days, convert it to seconds. Ladies and gentlemen, if you're given time in weeks, you know you've got 7 days in a week, convert it to seconds. Ladies and gentlemen, if you're given time in months, good people, convert it to seconds. Ladies and gentlemen, if you're given time in years, convert it in seconds. Okay, so we convert time to seconds. It doesn't matter in what form the time is given to us. Okay, but they won't go that deep. They'll just give it in minutes or hours. Okay, so they said 2 minutes multiplied by 60 seconds. Okay, this is how you convert it to seconds. Guys, you just punch in everything on a calculator. You've got 14.4 into 1.8 into, obviously that is 120. It's equals to 3110.4. 3110.4 joules. Very much important, ladies and gentlemen. Energy is measured in joules. Okay, so good people, this was just allocated 3 marks. Okay, it was just allocated 3 marks. Someone is asking themselves, what if I used that formula from there? Okay, guys, this is how you'd substitute. Okay, what was your I? Your I obviously was 1.8. Then you square. What was your R? Obviously, you know your R is 2 times 4, which is 8. And then what is your change in time? Is 2 times 60. Ladies and gentlemen, punch all of this and tell me if you get the same answer. Okay, so good people, you score a mark for just writing the correct formula. Okay, guys, you score a mark for just correctly substituting. Okay, guys, you score a mark for your final answer. Okay, ladies and gentlemen, can you see how easy these things are, guys? If you fully understand exactly what you're doing, it's easy to give the correct answers. So I'll just remove all of these so that we move to the next question. So guys, I hope if you are still with me until this far, please make sure to like this video. It serves as an indication to me that I'm not in any way confusing you, which is a good sign that I should do more and more of these lessons. Okay, so guys, let's have a look at this question. It says 12.4. No, before we even get to 12.4, we're given a statement there. They said the 4R resistor is replaced with an ammeter. What an interesting one, guys. So what they are saying is that now this thing, it's replaced with an ammeter. Remember, guys, everything that I wrote here with a black pen or a red pen, it's not part of the original circuit diagram. Okay, I just added it along the way as we were discovering some information and some magnitudes of values. Ladies and gentlemen, now is replaced with an R. There's a huge impact that we have done to that circuit, ladies and gentlemen. What we actually did, we removed the resistance, or we moved the resistor that side. Okay, remember they said the resistance of the wires can be ignored. Okay, and you know an ammeter, guys, it has almost zero resistance. Okay, so it's more like there's nothing there in terms of resistance. Okay, so guys, that means we only have resistance on this side, but on that side of the wire we don't have any resistance. Okay, so it's more like it's just a pipe from there to there without having any either valve or any resistance in between. But this side we've got a we've got R there, we've got R there, we've got R there. So it's more like there's more resistance on this side, there's less resistance on that side. Okay, very, very much important, ladies and gentlemen. So now let's have a look at question 12.4. They say, how will the reading on the voltmeter be influenced? Right, only increase, decrease, or stay the same? Guys, the influence on the voltmeter as a result of replacing 4R resistor with an ammeter. Remember, guys, when you are confronted with this type of questions, just write this formula. Okay, they are asking about the V. Okay, so what have we done, ladies and gentlemen? What have we done? This is the V that they're talking about. Remember, what have we done? Remember, by replacing the resistor which was there with an ammeter, that means we actually reduced the current which was flowing through this side, because more of it will flow through that side. Okay, why? Because there's less resistance there. Okay, so that means the the current flowing, it's going to decrease. Okay, so listen very carefully, guys. The current that I'm talking about is the current flowing through this side, which is the current flowing through the 2R resistor, is the one which is going to decrease. Why? Because now it's more like we've opened for more water to flow through that side, because there is no resistance that side. Okay, so obviously, because the current flow in this side is decreasing, that means you're going to multiply with R, with R, the same R, but the current is no longer the same, it has decreased. That means this is going to decrease. Okay, this is how it makes sense to me, in order to be able to explain it to you easily, such that you understand. Okay, so that means one thing for sure, the V won't remain the same, and again it won't increase, but instead it will decrease. Ladies and gentlemen, very, very much important that you write it in capital letters if it's given to you as an option, where they've given it to you as capital letters. So now let's move to the next question, guys. So remember, this question was allocated just 1 mark, so you just go a mark. Okay, good people, please do not guess when it comes to this type of questions. Just apply your mind. Okay, don't guess, no guesswork. Explain the answer to question 12.4. Ladies and gentlemen, I've already explained that answer. Okay, so there are a lot of ways in which you can explain depending on your understanding. Okay, so I'm just going to give you the points here. Okay, so you can just say ammeter has no resistance. The ammeter, very much important that you mention that the ammeter has no resistance. Okay, I don't want to give you a full answer, because the next thing someone takes this answer as it is and they answer it to the wrong questions. Okay, you need to understand what I've explained to you in order to provide the relevant answer. Okay, so according to what I've explained, in short, it all comes to no resistance through that ammeter. Okay, what does it mean, guys, if the ammeter has a low resistance? That means almost all the current flows through that ammeter. Okay, very, very much important, ladies and gentlemen. Almost all current flows through that ammeter. Okay, ladies and gentlemen, very, very much important that you remember at all times that you are actually giving reasons for your answer in question 12.3. Okay, so again, the other one may comment to say there's no current flowing through there. Okay, so no current flowing through the 2R resistor. Okay, by so saying, ladies and gentlemen, by so saying, you score yourself 2 marks. Okay, they can just give you 1 mark, 1 mark. Okay, depending on which reasons you've used, they just give you 1 mark, 1 mark. Guys, I hope you enjoyed this lesson as much as I did, and I thank you very much for joining. Guys, if you enjoyed this lesson, please do make sure to like this video, and it makes me very, very much happy when you guys refer your friends, because it helps our channel to grow. And again, ladies and gentlemen, please do be aware that some of the information that I provide, it was meant for myself to fully understand some of these chapters. Okay, it doesn't necessarily mean that you need to learn that information from your teacher or whoever. Guys, once again, towards the end of this lesson, I think it's worth it to mention that please do allow me to say, it's very much important that I say It's very, very much important, because what I'm about to say, ladies and gentlemen, it's very, very, very much important. Okay, massively important. Listen to this. A day without learning something new, it's a day wasted. Okay, guys, this brings us to the end of our lesson for today. I thank you very much. My name is Desmond, and I'm out.